Hi guys, so today I'm going to go over the lesson 2, okay, which is going to be infinite limits and limits at infinity. So we're really going to be talking about asymptotes, okay, both vertical and horizontal. Okay, so just a quick review. They give us this problem right here. So they first ask us, given this function, where would the hole exist? Okay, so remember a hole exists where you have a quantity on the top that would cancel with 1 on the bottom. Okay, so you can see that x minus 1 would cancel with x minus 1, so that would create a hole. So you'd have a hole at x equals 1. An even vertical asymptote is basically just completely referring to the exponent of the quantity. Okay, so if you happen to have x minus 2 squared, that would be an even vertical asymptote. Okay, and so we'd have an even vertical asymptote at 2. Okay, and you can see down below here what they're referring to as far as what a vertical asymptote does. Okay, so if you have an even one, both asymptotes on both sides of that value are going upwards, or they would both be going downwards. Okay, as opposed to an odd vertical asymptote where one is going down and the other is going up. Okay, so the odd vertical asymptote in our function here is the one with an odd exponent. So you would find an odd vertical asymptote at x equals 4. Okay, so some interesting things that you can think about with functions without even having to graph them. Okay, so we're going to do some infinite limits. So this says you have seen examples where a limit does not exist at a vertical asymptote. Such non-existent limits can be expressed as infinite limits if the vertical asymptote is even, or if you find one-sided limits. Okay, so we are going to write these as either infinity or negative infinity. Okay, so we're not saying does not exist, we are specifically saying which direction these are going to. Okay, so the examples below make you use your knowledge of even and odd vertical asymptotes as well as holes. Perfect. All right, so for question number 1, we are going to find the limit as x equals 2 from the right. Okay, so as you look at this, you say, okay, well, if I plug 2 in, I would end up getting 5 over 0, okay, which tells us I have a vertical asymptote. Okay, so what I'm going to do is I'm going to use what's called the sign analysis. I'll write this over here. Okay, and what sign analysis is going to be is just simply if I happen to plug in a number that's just a little bit bigger than 2, is it going to be is going to be positive or negative on the top and on the bottom, which is going to tell me if a function is going to go to a positive infinity or a negative infinity. Because I know at this point, since I have a vertical asymptote, that the answer for this question is either infinity or negative infinity. Okay, so if I choose a number that is slightly bigger than 2, let's just say 2.1, and I do a little bit of math here and say, okay, well, if I have 2.1 plus 3, that would be a positive number. And if I have 2.1 minus 2, that would be a positive number. Okay, so if I have a positive over positive, that means I'm going to a positive number. So therefore, I would be going to positive infinity. Okay, and just kind of as a FYI, since this quantity is to the first power, this would be an odd asymptote. Okay, so if you graphed this, you would see the scenario where the function would split apart. It would look like that scenario. Okay, so question number 2, they give us the same function, but now they give us from the left. So I'm going to start by plugging in a number less than 2. So let's say 1.9. Okay, and if I did that math, I would say, well, 1.9 plus 3 would be a positive number, and 1.9 minus 2 would be a negative number. So a positive over a negative makes a negative. So this would go to a negative infinity. Okay. Okay, so moving on to question number 3. Again, if I plug 1 in, I would get 1 minus 2, 1 minus 1 squared we get negative 1 over 0. There's a vertical asymptote that tells me. So now I'm going to figure out if it goes to infinity or negative infinity. So I'm going to go from the right, so a number bigger than 1 would be 1.1, let's say. So if I plug those in, 1.1 minus 2 would be a negative number. And on the bottom I have some stuff squared. Anything squared will be positive. So if I have a negative over positive, we're going to negative infinity. Okay, and just as a heads up on this, if I have a quantity that's squared, what kind of asymptote is that? Is that an even or an odd asymptote? So since we have a 2, you would see an even vertical asymptote scenario on the graph. Okay, so that's not what they're asking about. I'm just pointing that out as we go, just so you're clear on just some extra things about what's going on. Question 4 is exactly the same as question 3, but this time from the left. Okay, so I'm going to handle this the same way. I'm going to pick a value smaller than 1, so how about 0.9? If I plug 0.9 in, I would get a negative over a positive. And maybe we didn't even need to do that because we knew this was an even vertical asymptote and that they're both going to negative infinity. Okay, we could have gone straight to that fact, just knowing that. Okay, but we just kind of double checked it with our sign analysis scenario. Question number 5. Careful here. If you plug 2 in, you end up getting a 0 over 0. So what do you do if you get 0 over 0? Okay, hopefully you are saying you have to factor this because there is a hole, not a vertical asymptote. Okay, so if we factor this, x squared minus 4 factors into x plus 2 and x minus 2. The x minus 2's cancel out. So the function I'm dealing with is x plus 2. So then if I plug that in, 2 plus 2 would equal 4, and 4 would be my limit. Okay, so we could go further into this and say there would be an odd vertical asymptote. No, just kidding. There would be a hole at x equals 2. Hole. Not a vertical asymptote. Okay, so moving on to the next page. Okay, they start talking about limits at infinity. Okay, so what's happening to the graph as you go way, 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 way to the right or way, way, way to the left at infinity or negative infinity. So what I'm going to add onto these notes is they immediately start talking about horizontal asymptotes. Okay, so perhaps you remember this, but a quick refresher. Horizontal asymptotes have 3 different cases. Okay, first scenario, you're basically looking at the exponent, the biggest exponent on the top of your fraction versus the bottom. Okay, so for example, if I have x to the 4th plus 5x over x to the 4th minus 8x plus 1, whatever, all I'm looking at is the biggest exponent, okay? So first scenario, if they happen to be the same, then that implies we have a horizontal asymptote at, okay, and in this particular one would be at y equals 1. Okay, so the way I'm getting that is by the coefficients that are existing in front of those. So there's an invisible 1 here and an invisible 1 here. Okay, so the horizontal asymptote would be at 1. Okay, so another quick example on that one. Okay, so what would the asymptote be for this one? Y equals 2/5. Okay, so same They're the same. So we're looking right here. Okay. Scenario number 2 would be, let's say you had it bigger on the bottom. So let's say you have x squared, 2x squared plus 8x over x cubed plus 2, whatever. Okay, so again, we're looking here. Okay, so if it's bigger on the bottom, bigger on bottom, will always imply the same asymptote. You will always have a horizontal asymptote at y equals 0, and that will never change that number. Okay, the last scenario is if it would be bigger on the top. So if we switch that around, x cubed plus 2 over 2x squared plus 8x, so we got bigger on top. This would imply a slant asymptote, okay, which means the function would be eventually going up to positive infinity or eventually down to negative infinity. Okay, so if you're dealing with limits and you get this kind of scenario, you would have to graph it in order to see, or even just plug in a giant number and see if it's going up to a positive number or down to negative infinity. And we'll use our sign analysis again to make that decision. Okay, so just remember, bigger on top is a slant, so therefore will be either infinity or negative infinity. One or the other. Okay. So to use that in our examples, okay, number 6 says, let's find the horizontal asymptotes. Okay, so which case do we have for problem number 6? So I'm looking at 5x to the 4th and 10x to the 4th. Okay, they're the same, so therefore my asymptote will be at y equals 5/10, which we all agree should be 1/2 simplified. Okay, number 7, if I'm looking at our exponents here, I notice that 5 is bigger than 4, and therefore it is bigger on the bottom. So if it is bigger on the bottom, I have a horizontal asymptote at 0. Okay, for the last one, I've got bigger on the top, right? 4 is bigger than 3. Okay, so if they're specifically asking me about horizontal asymptotes, are there any horizontal asymptotes? Okay, there is a slant, but there is not a horizontal asymptote. So I'd say no horizontal asymptotes. Okay, so bigger on the top, there's no horizontal asymptotes. Okay, so now how do we use that to find limits? Okay, so notice that now on these questions, we're looking at problems that are going to infinity. Okay, so we're looking far, far out, and it's basically, we're looking at where these asymptotes are existing. Okay, so if we're looking for horizontal asymptotes, basically, I got a case of, oh, we did this one already, the same. So this limit is going to be going to 0, or excuse me, not 0, it's going to be going to 5/10, which is 1/2. So the limit for this one is 1/2. Okay, for number 10, again, I'm looking for, as x approaches negative infinity, I'm going to treat it the same exactly as infinity because I'm still looking for horizontal asymptotes. Okay, so horizontal asymptotes, I'm comparing here. It is bigger on the bottom, so therefore the horizontal asymptote is going to 0, so therefore my function would be going to 0. Okay, now the last one, okay, this is the slant asymptote scenario. Okay, so I'm going to graph this one to maybe give you a better visualization of really what all this means. Okay, so hopefully you looked at this function and said, okay, it's bigger on the top. I know it's a slant. It's either going to go up to positive infinity or down to negative infinity. So if I graph it, So we got 5x to the fourth minus 3x squared plus 2 divided by 10x to the third plus 3. Whoops. Plus 3. Okay, so we should visually see the slant going on as x approaches infinity, and really as x approaches a negative infinity. So I'm looking, infinity would be in this direction. So where is this function going? Is it going up to infinity or negative infinity? Okay, so the graph shows you that it is going to positive infinity. Okay, now if we were asked to do that question without a calculator, what you would want to do is put in the idea of a big number and then see if you would get a positive over negative. And really all you have to do is look at these, the first terms, because the idea is if you're going to infinity that these smaller terms become irrelevant. Okay, so if you're plugging in a positive infinity, positive over a positive, it's going to positive infinity. Okay, so we'll play a little bit more with that one later. Okay, so for question number 12, they start with giving us a factored form, okay, which if we are looking for horizontal asymptotes is not going to do much for us. We need to figure out what those first standard form coefficients would be. So what I'm going to do is I'm going to say, what would the first coefficient be? Okay, and I can care less about what happens after that. So I'm looking at here, here, and not forgetting about the squared there. Okay, so the first term I would have x squared from this piece if I FOILed that out, and then I would have 2x. So if I have 2x times x squared, I would have 2x cubed. And then I would have blah, 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 but I don't care. Okay, on the bottom, I would have 3x squared, which is what? 9x squared. Don't forget to square the 3. So I have 9x squared times another x, so that would make 9x cubed. And you'd have plus, 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 blah, blah, blah. Okay, so where's my horizontal asymptote? Okay, we've got same. So therefore, we're looking at an asymptote at 2 ninths. Okay, so we made note of that. We nailed that. All right, so rational functions like those above have at most one horizontal asymptote. So the limit is the same whether x approaches infinity or negative infinity. Radical functions frequently have 2 horizontal asymptotes. Okay, so let's talk about this really quick, what this just said. If they say rational, what are they saying? What kind of functions are these? Functions that are written as fractions. Okay, if we have a function that's a fraction, and a radical means we're talking about some kind of a root. Okay, so either square root, cube root, whatever kind of root. So if we see rational functions that have radicals in them, there are frequently 2 horizontal asymptotes. Okay, so let's talk about this with question number 13. Okay, we're still going to use the same idea of looking for the asymptotes, but we're going to have a plus or minus idea. Okay, so if we took this piece right here and said, okay, I'm not considering this, I'm looking at that first term. Okay, I have a square root of 4x squared. If I did that and took the square root of 4x squared, I would get 2x. Okay, and when I do that, I want to think, oh yeah, I kind of have a plus or minus version of this. Okay, so there's going to be 2 asymptotes. Okay, so there's going to be an asymptote at, let's see, we've got the first case where we have an x over an x, so there's going to be a horizontal asymptote at y equals 2 and y equals negative 2, so it's a plus or minus. Okay, so at this point I know I've got a 50-50. It's either going to be a positive 2 or it's going to be a negative 2. So I'm going to use my sign analysis and think if I put in a positive number into the x, I would have 2 times a positive number, an absolute value, that would be a positive. And if I put a positive number into the x, it would still be positive. So I know that I'm going to have a positive asymptote. Okay, so the positive asymptote is at 2. So this would go to positive 2. Okay, if we're looking at from the left, okay, we've got the same breakdown as before. We've got the absolute value of 2x over x. Okay, I know I have an asymptote at 2 or negative 2. This time if I plug in a negative number, I would have a positive over, plug in a negative. So that one would be going to the negative asymptote, which would exist at negative 2. Okay, so that should be enough to get you through the assignment. Okay, what I would like for you to do on the assignment is I would like for you to do problems 1 through 31. Okay, and that will be due on the next time we see you, so depending on which class is watching right now, either Monday or Tuesday. Okay, all right, we'll see you then.